would highly encourage you to go check out the companion site. Just Google the student resources for sensation and perception by your textbook authors. Be sure to check the fifth edition because the website for the fourth edition is no longer available. But when you do that, you should be able to take part in this RSVP task, and in particular, the one that I did for something known as the attentional blink. So what is the attentional blink? So you'll kind of notice that in the task that I did in the last video, I had to keep track of two different targets. And those two different targets could be present at different stimulus onset asynchronies. So for example, in this image, there are a certain number of letters before and after our first target, and then you have random letters in this target. But what's kind of interesting is that if you vary the presentation of items in a list, this is where you get the attentional blink. What you're looking at here is the position of the second target in the list relative to where the first target is. So I could have an instance where target 2 is immediately after target 1. Here's two letters after target 2, 3 after, 4 after, 5, 6, 7, or all the way up to 8, eight other letters after target 2. Now, what's interesting is that you'll notice that if I present target 2 immediately after target 1, most people are pretty good at detecting the target. You can see here percentage of target 2 detected given correct T1 detection. So in this particular example, noticing a white letter and then also noticing the letter X. So if I present the X right after the white letter, most people get it pretty well, especially if you play video games. What's interesting though is that you can actually see this drop off if they're separated by one item. So if I present this shortly after, not immediately after, but shortly after, possibly in the second or third position, participants actually fail to detect the target. And this is what is known as the attentional blink. It's almost like if you're focusing your attention on something, it's going to shift and you have to take a break. It's like taking a blink. Now you might be asking yourself, Dr. Gilchrist, why does the attentional blink not happen for the first item? And one of the best analogies that I've kind of heard about why the attentional blink works the way it does, I believe is actually provided by your textbook. Um, I want you to kind of think about this like you were trying to fish for fish using a net. So the target is your fish, your attention is a handheld net. Now, I want you to imagine that this is a case where we're looking for two fish targets. So we want two fish. So we have target 1, that's our first fish. Target 2, that's our second fish. So let's say that I present my second target immediately after the first one. That's almost an equivalent to me putting my net into the water to get the first fish, and the second one jumps inside as well, and I get them both. However, let's say that we're dealing with something that's shortly after, but not immediately after, position 2, 3, or 4. Now in this instance, I've caught my fish. I've caught that first target. I have to take my net out of the water and empty out that fish before I can dip it back in. In that case, odds are pretty good if I don't present my second target immediately after, but rather shortly after, I'm going to miss that second target until I have enough time to get my net, my attention, back in the water again. And that's how the attentional blink works. Try it for yourself. Actually, a lot of fun. So let's talk about some of the psychological effects that attention can have on neurons and on our brain. So at a brain level, we know that even early visual processing areas are actually affected by attention. So what you can actually kind of see here are cases where different subjects have been looking at items that they're supposed to attend to in the left hemisphere and the right hemisphere. And you can see that even in primary visual cortex, areas that we have to pay attention to can be enhanced, even if they're not actually in an area of our fovea or good vision. Now, there are three different effects that attention can have. First of all, it can enhance activity in a particular part of the brain, as you can see here. It can enhance our processing. So, something that's kind of interesting here, this can actually alter our processing. A fun little trick with attention that can kind of mess with your brain a little bit, focus on this top corner. You'll probably notice that this rectangle looks darker as you're focusing on it. Now I want you to shift your attention down here, and now all of a sudden this one looks darker. And you can actually get the same sort of effect even if you use color. Right now this one looks much, much darker to me because I'm focusing on it. But as soon as I shift my focus here, this one appears a bit more dark. So we can actually enhance the processing that we could do. We can enhance the activity in certain areas of the brain. And attention can also help us to coordinate different brain areas together. So, for example, we have an area like the fusiform face area, part of the fusiform gyrus that specifically responds to faces. We have another area called the parahippocampal place area. This is an area around the hippocampus that responds favorably to pictures of houses. Both of them respond pretty well, although weakly, to objects or other stimuli. Now, what's interesting is that if you introduce binocular rivalry into this, where your attention constantly has to shift between a face and a house and a face and a house, what we will often tend to find is that the fusiform face area and the parahippocampal place area will become active simultaneously because you constantly have to deal with that shifting perception. Now, what's going on at the cellular level? Well, there are a couple of different things. We actually find that attention can do one of three things to neurons. First of all, it can overall produce an enhancement of response. So here's the original response curve for different orientations of lines. So we can have attention providing an overall enhancement, so it just becomes more responsive in general. It's possible that the tuning could become more sharp. So here's our original rate of responding, and you'll kind of see that with attention, almost with selective attention, we kind of hone in on on more specific orientations, or we can have altered tuning. So maybe by paying attention to certain orientations, rather than having this original distribution of responding, we shifted over to favor items that are closer to 45 degrees. So we can enhance the response overall, we can tune it more sharply, or we can alter it. And there is some evidence that we actually do this. What you're looking at here are monkeys that have been trained to look at two different stimuli, and you can see that you can map the certain areas when they have to focus on the diamond stimulus. You can see that there's enhanced spiking and activity for this. When attention has to shift over to the circle stimulus, you start to see increased firing towards that particular stimulus. So let's briefly talk about some different visual attention disorders. Now, we have to talk about the parietal lobe with respect to this. None of these disorders are problems with visual processing. These people are not blind. But what we often tend to find is the damage to the parietal lobe can actually cause a person to not pay attention to their contralesional visual field. So if I damage the right parietal lobe, what I'm often going to find is that I am not going to pay attention to the left half of the visual field. Now, if I turn this person around so that what was in their left field is now in their right visual field, they'll see it. Compare that to somebody who has damage to their occipital lobe. Their case is not an attentional issue, it is a perceptual issue and a sensation issue. Somebody with occipital lobe damage is blind. Somebody with damage to the parietal lobe will have difficulty with visual attention. So one of the first things that we often will talk about is hemifield neglect or unilateral neglect. One of the things that we tend to find is that if you have damage to the right parietal lobe, as this particular person does, you will not be able to respond to stimuli in the left visual field. This is a lot less likely to happen if you have left parietal lobe damage. So what kind of things can you expect to see with somebody with hemifield or unilateral neglect? One of the things that we can actually do is test it with line cancellation. So the idea here is that when you're looking at stimuli, what you want to be doing is cross a line that perfectly bisects this line. So they're drawing a red line through the line to basically cut it in half. And what you can see here is that in general, they're able to bisect. For the most part, they're able to bisect these lines. You might actually notice that there is a bit of a bias toward the right. It's not always perfectly in half. Um, it's kind of shifted over to the right. But notice that in general, they don't pay attention to the lines that are in the left. If you have people actually copy figures or draw spontaneously, you will often tend to notice that they forget or do not pay attention to the left half of space, whether they are copying a figure or drawing from memory. Neglect can also actually be object-based. So if I present people with items like this, we will, and what's kind of interesting is that this is a case where even if you flip the item, they will still tend to neglect it. And we don't typically see that with visual field. So here I'm presenting somebody with two items, kind of a dumbbell. They don't pay attention to the left. If I shift that over, they're still not going to pay attention to it, even if I've now moved it into the right visual field. Now, something that often appears with neglect is what is known as extinction. This is an inability to perceive a stimulus on one side of a point of fixation when I have another object presented on the other side. So if I have somebody responding to an item in the right, and I also have an item in the left, they're not going to be able to perceive that stimulus. So let's briefly finish up by talking about features of attention in scene perception. Now, your book talks about the fact that we have two very different attentional pathways. We have what is called a non-selective pathway, where we're not really using selective attention. We're basically looking at the overall distribution of features across the scene. We basically get the gist. This is where scene guidance can kind of come into play. So we know that we're looking at a kitchen, but we're not really paying attention to all of the items that are in there. On the other hand, we do have a selective pathway which allows us to only recognize a few different objects. Now, whereas a non-selective pathway doesn't really have a bottleneck, we can, on some low level, notice everything in the environment without paying a lot of attention. For selective attention, you can only pay attention to so much. And our memory for scenes, shockingly enough, is pretty good. Brady and colleagues back in 2008 actually presented people with 2,500 different images of objects or scenes like these, and then gave them a recognition test. Which ones did you see? So it turns out people are pretty good at this. What we're not good at is detecting changes in objects. So in this particular case, this is a famous study of change blindness by Simons and colleagues that basically has a man asking a professor for directions. And then through a clever little trick, another actor comes in to replace the man. These are two completely different men, but this particular faculty member does not realize that the person is a completely different person. So this is change blindness. We fail to detect that an object has moved, changed, or disappeared. And what's amazing is that even if we're warned, we think that we'd be able to notice that change, and we usually don't, which is referred to as change blindness. Now, one of the things that will affect change blindness is whether the change is part of our central focus, when we are warned, or when we're looking at a change in type versus token. So if I watch a lamp change into a book, that's a type change. That's easy to notice. If the book changes from a red book to a blue book, that is a token change, and it's harder to notice.